Welcome back, everybody. It's good to see you in Module 4. You've made it past the halfway point of the course, at least in terms of time. You've accomplished a lot so far. In Module 1, you learned about remote sensing, and in particular about this technique called SAR, synthetic aperture radar. And that's something that, even people working in remote sensing don't necessarily work with. It's something that is really valuable, especially if you're working on rice, and something I am confident you'll be using in the future. Module 2, if you didn't have experience with computers, enough experience with computers, then installing a virtual machine running Linux, that's salute to you for that. Module 3, that's where the fun really starts. That's when we're actually using INAHOR model, software, with the images to come up with estimates of the planted area or the rice extent, and then also for the amount of production, the rice production, given some assumptions for yield. So you should feel confident that you made it this far, but I warn you that you shouldn't be overconfident, because there's a very sort of unstated problem that we haven't directly talked about yet, and that is, how do we know those estimates are correct? Right? We came up with maps in Module 3 that, if you know the area, they look pretty good, right? But you don't really know if they're right or not. So you run this risk in remote sensing. I've seen a lot of people do this. If you come up with something that looks good enough to just say your work is done, your work is not done. And that is what we're going to be doing in Module 4 and 5, is looking at how to, first, in this module, get auxiliary information, namely through field work, to first ensure that the area estimates are correct. This extent estimates are as good as possible. And then second, we're going to talk very briefly near the end about the idea of getting information on actual yield, either crop cutting or farmer recall surveys. Very important things. And then Module 5, we're going to go in and actually revise the parameters, the threshold values of the INAHOR model to come up with the best estimate that we can come up with. So what I wanted to do very briefly in this introduction to Module 4 is to talk about some of the features of INAHOR, but also some of the things you have to be cognizant of, the sensitivity of some parts of the model. So for example, you should remember this slide. This is a really, really important slide from Module 3, in which we looked at how SAR backscatter changes during the year, at least for the inundation periods through the vegetative stages for a rice paddy. You remember through inundation time, this is a very low value because water itself does not backscatter very well. And then vegetative period, this backscatters very highly, so you get a much higher value. And what we did, this was really the key equation here, this condition, right? We had a threshold 1 value, and this set the upper bound on what value we would give a pixel that we thought might be inundated. So if the threshold 1 was set at a certain value, and if the actual pixel value is below that value, then it becomes a candidate for rice planted area. On the other hand, we also had something called threshold 2, which is based on this difference between the minimum and the maximum, the range. And if that range is greater than the threshold 2 value, and if this first condition holds, then we say, yeah, that's probably a rice planted area. Now, the trouble with this approach, and it's a great approach, and it's what we need to do, but there's a danger here in that we use the defaults, -15 for threshold 1, and then 3 for threshold 2. And the results looked okay. If you know the area, it looks okay. If you change these thresholds, let's say, for example, threshold 1 of -25 and threshold 2 of 6, we lose almost all the area. And what happened here? If you imagine going from threshold 1 value of -15 down to -25, that means that the darkness, the lack of backscatter from a given pixel, must be even less in order to qualify as an inundated area for that first phase. And the same thing with threshold 2. When we tighten this, going from a minimum maximum difference of 3 to a difference of 6, that means it really had to change its value from dark to light. So tightening those constraints, those thresholds on both sides, results in something that's, well, frankly, in this case, we know is a gross underestimate. And you wouldn't be using these values anyway. On the other hand, let's say we went from -15 up to -10. That means that that first inundation stage, even if it's got a pretty high backscatter, you're going to be saying that it might be rice. It might be inundated indeed. And then the threshold 2 value, if you give it a low range of 1, it doesn't have to change that much in order to get, to meet this condition down here. So what you end up in that case is, well, here we know it's an overestimate of the total amount of rice under cultivation or rice area, rice crop area. So these threshold parameters are really important, and there's something that we're going to be working on in Module 5 to change and to get as close as we possibly can to the actual values that they should be. The way we do that is going to be based on this field work that we're going to be talking about in Module 4. We will be showing you, first of all, how to come up with a random mesh, random points with a random mesh, how to design these, I don't know what we should call this, sort of like a template based on a high resolution image. So this can be used by people going to the field to actually do enumeration outside, to say that, okay, this is a forest, this is a field. We're going to be talking about how to do that. There's also photographs that need to be taken for the record outside in the field. There are notes, forms, that data will be converted into spreadsheet form. And then what we'll be doing is using this information to refine the threshold 1 and threshold 2 values to come up with the best estimates possible. This module is very much about using QGIS. If you don't have experience in QGIS, that's okay. We'll try to lead you step by step through coming up with these random points, meshes, how to do this analysis, how to look at the images that we've produced in Module 3. So Module 3 is about INAHOR. Module 4 is also about INAHOR, but mostly about QGIS. And then Module 5, a lot of work with Excel and INAHOR, QGIS, everything, to bring it all together, to really refine our work. So it's an exciting time. You're almost getting near the end of this. Hang in there, and I'll see you in the course.